Well, good evening or morning or afternoon, everybody, from wherever you are. My name's Scott Burleigh. I'm Vice Chair of the Interplanetary Chapter of the Internet Society. I'm here just to very briefly introduce Dave Israel, who will be presenting this IPNSIG Academy talk on the role of DTN in LunaNet. A few notes on Dave. He is the division architect for the Exploration and Space Communications project at Goddard Space Flight Center in NASA. And he's also the principal investigator for the Laser Communications Relay Demonstration mission, that's LCRD. He has been at Goddard Space Flight Center since 1989. He led a project to connect the Earth, the South Pole of the Earth, to the internet by means of NASA's TDRS system in 1997. So he's been at this kind of space networking work for quite a long time. He was principal investigator for a shuttle payload that demonstrated mobile IP and other networking functions through TDRS and ground stations in 2003. He's been a part of the NASA dilettante networking research and development team for about 20 years, leading some DTN demos, such as with the Lunar Laser Communications Demonstration Mission and connecting Antarctica to the International Space Station using bundled protocol over multiple hops. And he is co-chair of the IOAG Space Internet Working Strategy Group. That's the Internet Operations Advisory Group, Space Internet Working Strategy Group. So he's amply qualified to talk about the role of dilettante networking in the upcoming LunaNet initiative. And with that, let's see, one last note before I turn it over to Dave is, if you have questions, please enter questions and comments in the Q&A panel on your browser rather than in the chat panel, and we'll pick up those questions at the end of Dave's talk. With that, let me turn this over to Dave Israel. Dave, please.
Okay, thanks, Scott. And hello to everybody. I'm excited to be talking to this group, especially because I know it's worldwide and people are tuned in at all hours for this, and that's pretty exciting. So I'm going to talk about LunaNet. I'll tell you what LunaNet is with an emphasis on DTN, as was mentioned. Let me get my picture going. Here we go. This image here is actually the picture that I sort of commissioned to put on the cover of this presentation when we first responded to this study about lunar communications and navigation architecture. And the reason I thought this picture was important to kick it off is that I really wanted to make the case that what we really should be setting out to do is to look at everything from the user experience, and I wanted to make this direct analogy to our Earth user experience, operations concept of operations, where now we have devices that are have applications on board, and they're able to access information, and the applications will go out and get information based on where you are. So there's position, navigation, and time that's tied into this. And then we also get kind of weather and other warnings, and we can just you go on travel and you can find a place to eat, and all the things that we do that have now become our regular way of operating on Earth. We want to get to the point that for the explorers in the future on the moon and other planets, that same sort of thing is possible. So don't expect there to be actual tablets in use on the moon. They'll probably put them in the heads-up display or something. But everybody should get the idea and the important thing, and one of the things that I find beneficial being in the communications and navigation part of NASA's job is that it's things that it's a technology that people are used to with their everyday life, so it's easy to do analogies for it. So one of the things though that comes up when talking about this network future for the moon and interplanetary network, solar system, internet is the explanation that comes about well, we want to have that experience and that capability, but that doesn't mean that we can use the same protocols and do things the same ways that we do it with the terrestrial network. Right. So LunaNet defined these generic nodes that would be part of the LunaNet infrastructure, and there's 4 types of services that a node may provide. Nodes aren't required to offer every type of service, and the capabilities of each service will vary. But there's the communication service, or sometimes referred to as specifically as network communication service, position, navigation, and time, detection, information services, and science. So if I were to define like what we have here at Earth as EarthNet with these same types of services, then the communications services and the network services are everything from your local Wi-Fi access point to the local cell service, to now even satellite phones and things. And there's this basic idea that that every link is not we stop thinking about end-to-end links. What the users are always thinking about is just getting onto the network, right? So the average user doesn't worry about whether their phone is getting the data through the local Wi-Fi connection or through 4G or 5G, as long as it's working, right? You want to have that freedom. You just get that first connection. PNT would be an EarthNet, would be the GPS system. The detection and information services. Here it's more likely that maybe we'd get hurricane warnings or tornado warnings, perhaps, but other types of weather events and things that we get the warnings that are sent to our phones. This is the equivalent functionality in the LunaNet infrastructure, but this would be for solar events, things where you want the astronauts to take cover. Maybe robotic systems would need to do certain things, either to get into a safe condition, or maybe that's what the science is about. So they would turn on a detector to measure things. And the final category service, this science service, is the idea where the links themselves can actually be used to make scientific measurement. If you have 2 nodes orbiting the moon, or multiple nodes orbiting the moon, and you're doing very accurate ranging measurements between them, then actually that can be used to help refine the gravity map of the moon, for example. So that's what the science services are. There's a document we call the LunaNet interoperability specification. Version 4 just came out a few weeks ago, and I think I failed to include the link in the document, but I can post it in the chat, or if somebody finds it, they can post it in the chat. But it's publicly available. We released it jointly with the last few revisions. NASA and ESA have been working together for this document called the LunaNet interoperability document, and I know David from ESA is presenting next week about Moonlight. And you'll hear that we've been working together because we want this larger network to be an infrastructure that is implemented and operated by commercial entities, multiple government entities. But from a user point of view, maybe you're getting roaming service, but wherever you are, you can get a connection and get your data through. So in that interoperability spec, there's a section that talks about the communications services, and has and starts to identify the standards and identify the protocol stacks. Right? So there's this basic picture showing the idea that really think about the communication services as more of a per data flow as opposed to per link. And so a mission might have a link to a relay spacecraft, but there'll be some real-time data needs. Maybe it's sending voice from an astronaut on the surface back to Houston real time. But then there's also store and forward communications, and of course that's where bundle protocol really comes in. Though of course it can be used for real time as well. And then there's messaging service, which I'm not going to get into too much today. But the basic simplified protocol stacks you see below, and one of the things that would be noted and especially by the community dialed in tonight is the idea that the user applications, there might be a limited case where maybe they're going straight to the link layer, but the user applications, we are really working to get this to be a network. But you see that both bundle protocol based applications are shown to exist, and internet protocol applications are expected to exist. And you see the variations of how bundle can go over IP or straight into the link. So there is a paper. It's a pretty short paper that you see referenced on the chart here that we published out of the IOAG to just sort of help to explain this question about IP and bundle protocol and the when and where to use it. There's been sort of this truce, I would call it, in the argument about IP. In the beginning, it was like IP versus BP, and I think we've gotten to a place where we don't really argue that way, the same way anymore. It's just discussions about what will work based on the application that you have and the location of your endpoint. So to illustrate that, you see on the top left of the screen, there's a rover on the surface of the moon and lander, and let's say that there's astronauts inside the lander that are joysticking, driving around the rover. So that's the indicated as rover teleoperations. But at the same time, the rover is maybe taking a bunch of pictures, gathering bulk science and other information, perhaps. And what's shown in this picture and the various stacks is that it is expected that on the surface that there'll be an IP-based network happening, Wi-Fi, or we've been looking at 3GPP. It's like cell phone type technology. And if the application is expecting end-to-end connection, real-time driving the rover around, there might be already existing applications, then that could be an IP-based application. However, if the rover is looking to exchange data with an endpoint, I'd say anywhere in the LunaNet, which from the definition is not just any lunar users on and around the moon, but LunaNet connected users would also be the science operations on the Earth or other places on the Earth. So if that rover is trying to exchange information with anything anywhere in the larger LunaNet, then that's where it would be bundles that would be addressed and work their way through. So what that series of pictures is trying to show is that here in the lower left, that's just your basic, it's showing a TCP-based application that's just being used locally there on the surface of the moon, while that end-to-end connection from the rover all the way to the Science Operations Center, you see on the moon point of view, it's the application is directly working over bundles, and those bundles could be straight over IP convergence layer, like you see in that picture on the top right. And then the bundles are what gives you that end-to-end. You see that on the top right picture. I've been trying to promote the term BOP for bundle hop. So if you all want to spread that around, I appreciate it. And the idea, the reason why I started talking about BOPs is because we all know there's cases where, like on the terrestrial internet, where you might have two DTN nodes are talking directly to each other in a DTN network point of view. So it's a single bundle hop or BOP. But there's multiple IP hops or other connections that happen. So that combination of convergence layers and the various protocols to get you from one bundle node to the next bundle node is over a single BOP is what I've tried to just kind of label this BHP as bundle hop protocols. I've found in a lot of conversations. Until you get to the implementers that really need to understand the details, sometimes conversations get lost where people get confused because you have a bundled protocol in a stack and IP, TCP, IP in a stack, and people get confused because they think there's multiple network layers, right? So by displaying it this way, I'm trying to show, and this is what that lower right picture is about, how the larger network, it's a bundled protocol based network, it's a BP network, and there's portions of that network that the bundles travel over, where it's the bundles ride over IP. So there's the short paper where I tried to describe this further. But one of the key takeaways that I'm trying to promote is that it really comes down to the applications, and I think the for things that were applications that are being written now or planned now for lunar exploration, or even terrestrial cases, if the application does not have the same assumptions that require an IP network to be functioning underneath, then if the application just natively worked over a bundle protocol, then that would allow that application to work under all cases, and work then throughout the larger solar system internet or interplanetary network. So this picture is also trying to illustrate the idea that LunaNet is a disaggregated approach. There's not a single constellation that's going to be called the LunaNet constellation. It's a combination of various spacecraft and types of spacecraft, systems on the surface, systems in various orbits around the moon, maybe some pieces orbiting the Earth might be a part of it as well. And again, there's a lot of desire and understanding that for what we want to do, NASA doesn't expect to implement and operate this all ourselves. And clearly, ESA has already had that conclusion, and they have their Moonlight initiative. So from the beginning, we're looking to have this interoperability. And one of the keys that we've seen for interoperability and then end-to-end functionality is the networking approach. And again, that's where bundle protocol is key. There is so we've publicly stated with NASA we're going out for a procurement of looking for service providers. The RFP is scheduled to go out some point in November, and part of what is included in that search for service providers are for lunar relay providers and basically LunaNet providers that then we would get our services from. And we hope and the expectation is that others would get services from them as well. So this is my last slide, because I'm looking forward to the questions and the interaction. So, but the key points. So if and when you look at that LunaNet interoperability spec, you'll see that BP v7 is defined to be that protocol for that end-to-end networking. It says something to the effect of what I said earlier, that if you expect your data to be able to get from anywhere on point A on the LunaNet to point B on the LunaNet, then bundled protocol is what you should be using. And things that I'm hoping that people on this call are working on we've done a lot of work on the implementations of bundled protocol on the protocols and like the infrastructure pieces, but when we're charging right into, like, we're in a lot of ways we're at the ARPANET phase for the moon, but it feels like we're trying to jump straight to 1990 or the modern day very quickly. So there's lots of things that we have to be working out. So this whole peering relationships, but it's different. It's not like you're going to be on one part of the moon and then go to another part of the moon and have a different provider. The providers are going to be orbiting around you, and you'll be in the same place as the providers change. So how to work that peering relationship, service management, and routing, security, I should have added to the list as well. And then that last point, again, the applications, I think that'll really help to establish the DTN in place, is that collaborative science payloads or experiments that are sent to the moon, things that are sent to the moon at different times, and maybe they're different projects, but because their communications is network based, it makes it straightforward to start to share data before and share measurements between platforms. Those types of applications that make all that science and exploration happen, I think are things that it would be excellent to have being developed and part of our demonstrations, instead of just showing basic file transfer over bundle protocol, for example. So I believe that is my last slide there.
Okay. Thank you, Dave. Very informative presentation. Let's pick up questions and answers for a little while. Once again, if you have questions about anything that Dave was talking about in this in these slides, please write something to the Q&A panel. And if it's in the chat panel, we may pick it up, but the Q&A is where we'll really drive the question and answer discussion from. So the first question I see in the Q&A panel right now is from Jorge Amadeo, and he asks, how do you plan to handle timing clocks in LunaNet?
Yeah, so that is it's actually more complicated. Being mostly a common networking guy, I've been learning how it's more complicated than I thought. So there is work to develop not using the exact same signals, but a GPS like infrastructure around the moon. So that would give some timing and frequency references to the moon. But one of the things that I'm learning from those working on it is just like the whole frame of reference for time at the moon is something that still hasn't been decided or worked out. And there's factors with the gravity of the moon and relativistic effects and things that when people are talking about making precise time and measurements, there's actually quite a bit of infrastructure challenges that folks are now working on to address the PNT, and that's a level of precision much greater than keeping the clocks accurate for the DTN needs, but just for the antenna pointing and the science capabilities. That's why one of those that top level service of the LunaNet infrastructure is that position, navigation, and time aspect.
And there's a follow-up from Jorge that I'll, even though it's not actually the next question, but I'll skip ahead to it and then come back. Jorge asks, what about atomic clocks on spacecraft? Do you have any insight on the plausibility of deploying those sorts of clocks in?
Yeah. So there will be some atomic clocks on spacecraft. I guess part of the desire, though, is to not require them on every spacecraft. Right? So there could be certainly things that are part of the infrastructure that are providing the references. You want to have precision there so that you're not introducing extra errors. But if we want to have as low cost as possible platforms and experiments landing on the moon, then it would be better not to require a precision atomic clock on every mission if you have other ways to get time updates and keep them synced up to the accuracy that they need.
Fair enough. Okay. Well, a question from Scott Johnson. How do you envision the peering mechanism working in the LunaNet?
Yeah, so we're really just starting to work it out. It's part of so it'd be interesting to ask this question again with David Otero next week about Moonlight, right? So we're starting to talk about that. Certainly there'll be at the top level, there'll be sort of agreements about passing each other's traffic, being able to support other agencies or different users. The part that's more complicated or more technical to work out are things like how are we going to sort of share any kind of status or contact plans and things between providers and you want the equivalent of sort of autonomous systems or people to have their nodes and their pieces that they're responsible for, and we're not expecting there to be one central place that has complete visibility into everybody's system. So understanding that level of insight that's required and how to coordinate it and how to put it in both technical interfaces so that things can exchange the proper information, combined with how to put it in service level agreements and contracts and deals. So that's one of those areas that is actually coming upon us quickly, I think, and it's got a lot of complexity to it.
Actually, my own follow-up on that question is, do you anticipate a lot of the configuration parameters for the LunaNet being confidential, that they would not be open, being exposed to everybody that's participating in the network? Do you expect to need those sort of informational firewalls?
I think it might be mixed. I think we have to expect that it'll get to a point where some people might be protecting their information more than others. Just and so we're trying to design that all in from the beginning. We may have some near-term luxury, as it were, where if we're going originally and it's like the IOEG agencies that are working together, where we already have ways that we do cross support and things, then we'll have certain security standards that we'll have to live to, but it'll be a little more manageable in the near term than like the longer term view. Sure. Certainly we have things like BPSec to provide that type of confidentiality and things, but if we ever get to the point where there's certain users that want to only use some providers and not other providers and things, then that complexity will come in.
Sure. Well, okay. A question from Laura. Is there what's the current status on on the laser comms testing? Is there are there tests coming up soon? What's the progress?
Yeah, and thanks for that question. So we have our first DTN experiments over LCRD is configured and ready to go. We're working through the final. It's a good follow up to that previous question. Going through all the security stuff to get the network connectivity to happen. That always seems to be the last thing, the last piece to come together. So we anticipate in November. We'll start flowing some DTN bundles through LCRD between the two ground stations. And then we have a series of continuing experiments to still relay through the ground stations, but with multiple implementations of DTN. So the first experiment is using ION, but we're also planning to use, there's HDTN that's been developed in DTN ME, and we're going to test them all and do interoperability between them, et cetera. But then we're also looking to expand our network connectivity to allow us to flow bundles beyond just our ground stations, so that then we can connect to. It'll probably be first. It'll be easier, probably within the NASA networks to do some larger experiments. But I have already put in the requests, and I'm working through with our network security people that I very much want to be able to connect the LCRD links to the test network and what IPNSIG has been doing, so that then I would really like to see some applications that people are working on out there in the IPNSIG universe, as it were, where we can flow bundles to all sorts of places, and some of those addresses will go through the NASA's LaserCom links. And then early next year, there's a payload. The Illumity payload is scheduled currently for mid-February to fly to the International Space Station, and then we'll be doing some DTN bundles to and from the space station through LCRD, and then maybe we'll be able to even add that to that larger test network.
Very cool. This is a rapidly expanding capability. This is really cool.
Yeah.
All right, a question from Oscar Garcia. He points out that he'd like to test his medical records for space system, which is based on ION. Is it going to be possible to do that within LunaNet? Is there a way that sort of non-NASA application could be introduced into the LunaNet flow? And if there is, then what would the timing of that introduction be?
Yeah, that's a great idea and a good question. So certainly I would like to make that happen. Right now we don't have like an equivalent yet of like a DTN experiment node planned to go to the moon. That would be certainly a good thing for us to be able to do, to have a test node where then we can upload people's software and things and do a variety of demonstrations. So right now the only path that currently exists is you would have to work with somebody that's planning to send something to the moon now and get your experiment incorporated into that. I do think that is a worthwhile goal, and it may be something we've talked about. That how are we going to validate when a provider shows up at the moon? How are we going to check it out, make sure it works, and things? So I do think that at a certain point in time we'll have some test nodes and things on the moon, and then once we have that, then I think there'll be the possibility to open it up for demonstrations of applications. Again, I do want to emphasize that application part, because like one of the things I like to point out is it's like my parents weren't bugging me about how to get on the internet thing until they heard about the World Wide Web, and then they wanted to get on it, right? So
Right.
Once once I think there's some applications and things that the scientists or people hear about, and they like, hey, I want my mission to be able to do that, then they might not even know that DTN is the thing that makes that happen. They just know that they want to send these things to the moon and have them talk to each other like they heard was possible, or their friends are doing, right? And
Right.
and that really flows from the applications, and then demonstrations of those applications are the best way to, I think, help to get that user pull that we've been looking for.
Right. Right. Yeah. Streaming movies. Yeah.
Yeah.
Okay. Another question from Laura. She points out that we're seeing an uptick in the use of the quick protocol on the internet. Is anybody looking at a UDP-based protocol for space communications that you're familiar with?
I know when like, I guess now it's like 20 years ago when we did that shuttle experiment, then since that was all in low Earth orbit, we did it all IP based, and then we used I guess now it goes by the name Norm. That was kind of like a UDP based way to exchange data. I think we were at the point where like a discussion for LunaNet, where we're really trying to discourage, even though UDP would work for that end-to-end connection, with the distance to the moon, we're trying to discourage, and you'll see it in the document, working to discourage the use of like a UDP based application to get your data to anywhere on the LunaNet, because that would still assume that you had this end-to-end connection in place, whereas we're seeing your relays coming and going and links coming and going. So unless you wanted to risk the data not making it to that endpoint, then you could go with UDP based. But then from the scalability problem, there's usually gets a point where you need to start bringing in the domain name services and other aspects, and that's why we're trying to working to steer things to bundle protocol based for those applications.
Sure. Okay. A question coming back to the time question. What's the plausibility of spacecraft that do have atomic clocks acting as NTP servers? Is there an expectation of NTP working in portions of the LunaNet or end-to-end in the LunaNet?
Yeah, well, certainly in like the regions where there's an IP network, I could see having like a local time server for that. I've heard some mention from a colleague about like a NTP type service over DTN, which I'm kind of curious to hear what he's got in mind. But certainly I do think that as we discussed, time is a challenge. One of the benefits of if we can find a way with like a network protocol way to get time accuracy to the level that particular node needs, is that might spare that particular node from having to have some other hardware on board to receive and process the other signals to get PNT service, for example. If it's already connected to the network and it can get its time synced up well enough for its needs through its data network connection, then certainly that would be beneficial, probably for a lot of users.
Okay. Yeah. Okay. On a slightly different tack. In again, thinking about peering arrangements, how would opportunistically discovered contacts with opportunistically discovered neighbors be integrated into contact plans in conformance to peering agreements? Has anybody gotten that far in the thinking about that?
We're not that far yet. So open to any So certainly in the near term, it'll be peering agreements with scheduled contacts.
Sure.
Right. But I do think, and again, if the buildup at the moon goes at the speed that some people are talking about, it might go quickly if there's a launcher that can like distribute like a lot of small sensors, on the moon or science platforms scattered all around. We might get there quicker than some might think. And so I don't know exactly how it would be done, and but this is really part of. I mean, to be honest, part of why I was excited about the opportunity to talk to this group is because, like now there's hopefully people around the world that are thinking up these problems and then working on solutions for them.
We're right at the edge of the envelope here, I think.
Yeah.
Yeah.
Right.
Another question about integration of applications, I think. If there were, I'm just trying to think of a way to pose this question. If there were something like an application gateway, maybe an application server someplace that privately developed applications could utilize to access the services of the LunaNet without actually being integrated into the LunaNet. That seems like it might be a way to accelerate the introduction of applications. Is that a plausible idea? Is that anything that anybody's given any thought to? Do you know of?
Yeah, I don't know. One of the things that I've been thinking about, and maybe this is a preliminary announcement here, but I was we can formalize it, but I was going to call it just like the LCRD, app challenge or whatever, right? Yeah. Just
LCRD at home, yeah.
Yeah, but well, not or just like people work on their applications, and at this point, I don't have any control to promise you that I will put the application at the moon and work to it, but I do have control to like get the application soon when we get all the network connectivity worked out, but to be able to run the application over top of our LCRD lasercom links. And then some of our experiments are to try and operate the lasercom links as if we're operating a relay, right? And then it'll be as close to this sort of like in order to demonstrate this type of functionality, and to have right now our first applications are really just we're going to have a bunch of bulk files, pictures of people's cats and things like that will just transfer from one place to another. But I think if there were other applications like collaborative science type applications or some other things that medical application, then we can just demonstrate it through the NASA link. It'll help with the visibility from both directions, I believe, and then we can see from there whether extending that to some that node that might be available on the moon in the future.
Sounds like a good approach. Good. A question from Christopher Lowe. How will network state be distributed through the network? That is, if a node presents as faulty, is there a mechanism to let others know and update the contact plan accordingly? How do you detect things that are going wrong and let people know about it?
Yeah, so that one I can't give you all the details because I don't know myself. I can tell you the one in this one picture. Let me try and go back to where I talked about the message service. So just going back to that, where I had the term LunaNet application. So I think of these LunaNet applications as being like sort of like control plane type messages and conversations. So the user applications are the things where it's like the source and the destination are two user systems, and the LunaNet applications I think of where either the source or the destination is something inside the network provider, right? So the types of messages that would be distributed could be scheduling information or network status information, those types of things. And one of the items that is in the LunaNet interoperability spec is this idea of we call it the AFS. I think it's the augmented forward signal or system. I forget which. But this would be it's a S-band signal that's being transmitted down by orbiters, and it's a combination. It will have signal structure to it that it can be used for GPS like PNT functionality, but also it'll be able to carry some data rate higher than the very low data rate that's on GPS signals, but not a tremendously high data rate. But that's where certain types of like network messages and things can also be sent out and kind of always being broadcast, so users can listen for that.
Okay. And all those messages would go out over bundle protocol as well, so they would be able to survive link outages and so forth. So
that's right. And the messaging is and those folks interested in that, when you look in the internet or the interoperability spec for LunaNet, you'll see that we haven't really developed there's a lot of TBD under that. I could do more to describe what I think it should do or how I would like it to operate than to actually point to something. But one of the key pieces illustrated in this picture is the idea that the application is sort of abstracted away from the underlying some of these things, like so some things like a solar flare alert. There's application that says, hey, it's a solar flare, and then it's just like sends it to this messaging system that will then forward it over all of the appropriate links and paths that it has. So some messages would go, oh, you see the AFS there, right? So it just goes straight down to whoever's on the other end of that broadcast system. Some of the messages are things that you want to put on bundle protocol, and that's where like the discussion of multicast like things would start to come in as well.
Okay. And I think the last question I see on here right at this point anyway is again from Oscar Garcia, and this goes again to the at least in my mind, it goes to the sort of question of how open the LunaNet is going to be. Of course, it has to be carefully protected because these are extremely valuable and vulnerable assets out there. Is there any expectation that during testing, for example, the LunaNet might be connected to terrestrial DTN networks, such as the one that IPNSIG is setting up for the pilot projects?
I wouldn't say it's a definite no. I'd say it's a maybe. I think when we go through whatever it is we'll have to go through to do the LCRD tests, I think we'll learn how difficult that might be, and maybe we'll figure it out. And then at that point, we'll be able to then see if we can identify something that's going to the moon, or is maybe in a like it did its primary mission at the moon, and now it's in extended operations phase, and we can use it as a test node. So it's certainly something to consider. Again, I'm a proponent of it because I do think that the more people that are thinking up the applications and trying to demonstrate it, I think that will really help to improve the technology, underlying technology, and also get the awareness and the interest. So it is something to keep talking about and pursuing.
Great. And I think that's actually okay. I see one more question, and then maybe it's time to start wrapping up. Scott Johnson asked, what's the best mechanism for private and non-governmental entities to arrange to participate in LunaNet in some way? Is there any sort of outreach kind of arm for LunaNet?
Yeah, there is actually. So when we published our LunaNet spec, then there's an organization here at Goddard. It's the acronym is CIS. It stands for something like Commercial Innovation and Synergies Office or something like that.
Yeah.
Right? But they've been setting up, like there's been forums where like when we've released the update of the LunaNet spec, then an announcement goes out, and myself and others kind of talk through it, and we solicit comments from industry to come back, because we are very much interested in again having multiple providers and different people, and really see it as the same type of I don't know, ecosystem, if that's the word. That's where that the internet was, right? Where there's roles for big providers and big companies, and even you know, everything down to folks that are just an app provider, right? And everything in between. So I'd say that CIS office, I can if people want to send me emails with questions, actually I'm happy to do that. That might be the easiest way. I'm just dave.israel@nasa.gov, and then I can connect people up. So that office has basically a mailing list that when we have like those types of events, then people can be notified. And it's the same group that for those that tuned in and participated on the industry day for IPN for the NASA DTN meetings that we had not too long ago, then it's that same organization that put that together.
Okay, great. I think it's probably time to defer any further questions to email and to wrap up for this session. Again, thanks very much to Dave for this presentation and answering a lot of questions. Thanks for everybody who wrote questions. Some very interesting and kind of illuminating points, I think, coming out of the discussion here. We are at this point, I think, going to go through a couple of slides right at the end, talking about IPNSIG and more broadly, and IPNSIG Academy in particular. First of all, here's a list of the upcoming further IPNSIG Academy keynote talks, starting with an ESA Moonlight overview. I don't see a date for that, but it's going to be sometime in November. And then Ed Burleigh of Johns Hopkins Applied Physics Lab will talk about IETF standardization efforts. Ed is one of the co-chairs of the IETF Delay Tolerant Networking Working Group. Keith Scott will talk about standardization within CCSDS, the Consultative Committee for Space Data Systems. He's chair of the CCSDS DTN Working Group. Laura Donardis will talk about interplanetary internet governance issues in February. Scott Pace of many years at NASA will talk about space policy and a perspective on IPN governance in March. And there will be a more general workshop on architecture and IPN governance in April. Next slide. The IPNSIG is actually it seems to be growing. Actually, we get new people coming in every day or so. 800 odd members and really all around the world. And not just from North America and Europe, but really quite a lot of participation from Asia, Africa, and South and Latin America, and as well as the Arab states, the Middle East. There's a lot of participation worldwide. If you dialed into this presentation and are not already a member of the IPNSIG, it's easy to do. Just send a message to membership@ipnsig.org. There's no charge. Next slide. Oh, Dave, oh yeah, there we go. And let's see, there's a survey. Here's a QR code to take the survey, or you can go online to this survey. I think you may be taken there automatically upon the conclusion of this slide deck. And I think there may be one more slide.
Sorry, I'm a little slow on here. Nope, that's it.
Oh, that's it. Okay. So that's our entire presentation for today. Thanks to everybody for participating, taking an hour out of your day and joining us for this discussion. Please feel free, again, if you're not already in IPNSIG, please feel free to join. There's ample opportunity for discussion of these questions on the IPNSIG mailing list. And with that, I believe we're done for this, well, for me this evening. Thanks very much again, everybody, and see you in another month, we hope.